Hi, my name is Elena Loveland, and for this final project, Nia, Ben, Molly, and I decided to investigate a data set we found on Kaggle.com that listed America's top colleges in 2019 as ranked by Forbes. So to give a little background on this data set, the data set consists of 650 colleges and universities in the United States, and it lists them in order of their ranking, 1 through 650. There are also other statistics on the institutions that are included in this data set besides their rankings, and we take a look at those. And as previously mentioned, all of this data in the file is based off of observations gathered in 2019. We were largely motivated to work with this data set because we all went through the college application and selection processes and agreed that visualizations are very helpful when it comes to the relevant variables and factors that you consider during your decision-making process. Additionally, a few of us have younger siblings that will be tackling this soon, and it just made the data set all the more personally relevant. Out of all the variables that were included in the original data set we obtained through Kaggle, there were 9 particular variables that were especially relevant, and we worked with them a lot. The first relevant variable was the institution type. This read in R as a character, and it listed whether the institution was public or private. Next, we have acceptance rate. This was read in R as a numeric variable, and it listed the percent of students who were granted admission to the institution based on the total number of applicants. Undergraduate population was also read in R as a numeric variable, and it listed the total number of undergraduate students enrolled in the institution. Total annual cost was also a very relevant numeric variable that listed the amount of money it costs each year to attend the institution. Average grant aid reported the mean amount of financial aid that students enrolled in the institution received annually and was also read in R as a numeric variable. Alumni salary was a numeric variable as well, and it listed the median salary the alumni of the given institutions earned annually after at least 10 years of work experience. SAT.lower and ACT.lower were also relevant numeric variables. These variables each listed the average composite score that students in the lower 25th percentile earned for their respective tests. And lastly, selectivity is a character variable that we actually ended up adding to the data set and working with a lot. We determined how selective an institution was, ranging from most to minimally, based off of their acceptance rates and information regarding selectivity found on collegetransitions.com. Now moving on to how we prepared, wrangled, and manipulated our original data set. Our data set was pretty clean to begin with. However, we did end up removing some unnecessary characters that we viewed as typos that cluttered the data and variables that we deemed unnecessary, like the website column that Kaggle included. We did utilize the mutate function to add a few columns to our data set. As previously mentioned, we added a column named selectivity in order to list how selective an institution was from most selective to minimally selective. We added a rankings column that categorized each institution as being in the top 10, 25, 50, or 650 of the institutions in the data set. Another column that we named campus size was added, and it categorized the institution's campus sizes as very small, small, medium, or large. And we did this according to the Carnegie classification system. A column listing the longitudinal coordinates, as well as a column listing the latitudinal coordinates of the state that the institution resided in, were also added in order to aid in data visualization. Additionally, binary values were mutated across the data set for logistic regression purposes. These values corresponded to the quality of financial aid based on the average net price of an institution being above or below the mean of $22,337, receiving a 1 if it was categorized as good and a 0 if it was categorized as bad. Further, the data was subset to highlight the various relevant variables New data sets were created to look specifically at private and public institutions separately, as well as at colleges and universities in Virginia. We were able to gather a lot of useful information by looking at summary measures of some of the relevant variables. For the institution type, the institutions were categorized as either private or public, with 400 of the 650 in the dataset being private. When looking at the acceptance rates of the institutions, the rates ranged from 5% acceptance to 100%, and the average acceptance rate across the dataset was 61.6%. The undergraduate population of the institutions ranged from 185 students all the way to a little over 65,000 students, with the average population size being right around 10,000. However, it's important to note that here, the middlemost value, the median, was around 4,500. Institutions range from $0 to around 75,700 when it comes to the total annual cost of attendance, and both the median and the mean were right around $50,300. Average grant aid ranged from a little below $3,000 to a little below $51,000, and the mean value was right around $20,000. And lastly, alumni salaries ranged from $70,700 to about $158,000, with an average of almost $99,000. Here, looking at the table on the upper left-hand side, we can see two categorical variables being compared. These are campus sizes ranging from very small to large by the type of institution, either public or private. As you see, the majority of private institutions are categorized as being small, whereas the majority of public institutions are categorized by being large. Moving over to the table on the upper right-hand side, we again see two categorical variables being compared, except this table shows the campus sizes and how they correlate with the institution's selectivity. As illustrated, the largest number of minimally selective institutions have a large campus size, and the institutions that are most selective tend to have a medium campus size. The table across the bottom shows a summary of numerical variables by groups. Here, the ACT lower is displayed across acceptance rates. This illustrates that the institutions that are more selective, having an acceptance rate of 35% or less, tend to have students that score high on the ACT, even in their lower 25th percentile. When comparing average metrics of public and private institutions, it is important to note that the average acceptance rate is about 10% higher at public institutions. The average undergraduate population is significantly higher at public institutions as compared to private. The average total cost of public institutions is lower than that of private institutions. However, the average grant aid shows the opposite trend, and the average alumni salaries round out to be practically equal. When comparing the Virginian institutions that were included in the dataset to all of the other institutions, all average metrics are practically the same, and they vary very little from each other. And when comparing the institutions that made it to the top 10 of this dataset to the remaining 640, the average acceptance rate was significantly lower, 7.5% as compared to 61.6. The average undergraduate population was lower by about 3,000 students. The average total annual cost was nearly $20,000 more. However, the average grant aid was also about $26,000 higher. And the average alum made about $40,000 more per year.
Hey guys, so I'm Ben, and right now I'm going to walk you guys through a little bit of the data visualization that we did for the Forbes Top Colleges in America in 2019 list. So we made a couple graphs to display the data. So the first one that we did was a word cloud, where we have represented here each institution by their acceptance rate. And the acceptance rate ranges that we used on this display are 5% to 28%. So as you can intuitively see, the bigger the word appears in the word cloud, the higher the acceptance rate. So for example, our University of Virginia right here, go Hoos, appears bigger on the word cloud. This is because our acceptance rate is around 27 to 28% in 2019. And on the other hand, we have institutions that are more selective that appear smaller. So for example, you can see right here, We have Harvard University and Stanford University. Both have acceptance rates of around 4 to 5%, therefore they appear smaller. Now looking at some of our more middle sized words, we have universities like University of Notre Dame or University of California, Berkeley that fall in the 10 to 15% range. So as you can see, it's pretty intuitive. The bigger the word, the higher the acceptance rate. Next, we have a box plot. And on this box plot, we have graphed the average annual grant aid received by students through all universities in 2019. So our minimum value all the way here at the end, at roughly around $2,500 of grant aid received. And on our maximum, right here on the right side, we have about $52,000, $53,000. Now, if we look at this middle line here, that represents the median grant aid received by students, which is around $19,000 a year. And then moving to quartile 1, we have around $9,000 of grant aid. In quartile 3, we have around $27,000, $28,000 of grant aid. Now moving on, we have our second box plot, which is a side-by-side box plot, which is the cost comparison by institution type. We have 2 institution types here on the box plot, private institutions and public institutions. As you can probably already guess, the median cost for public institutions is quite a bit lower than private institutions. So looking at private institutions, we have our median value here at around roughly $57,000 a year, quite a hefty sum. Our Q1 around $50,000 a year, and our Q3 around $65,000 to $66,000 a year. We have our maximum values up here at well over 80,000, actually approaching the $100,000 a year mark, which is insane to me. And then we have our minimum value here at around $29,000 a year. As you can see, we have 2 points down here representing outliers on the lower cost side at around $12,000 a year and around $19,000 a year. Now moving on to the public institutions, we have a median average annual cost, or a median annual cost of just under $40,000 a year, coming in at about $38,000. We have our Q1 at about $35,000 a year, and our Q3 at around $45,000 a year. Now you can see our minimum and maximum values right here. The minimum value being around $25,000 a year, and the maximum at around $56,000, $57,000 a year. Now there's a lot more variation in terms of outliers. So we have some outliers that are here towards the top, about 6 values, all hovering around the $60,000 a year mark. And then interestingly to note, we have 2 outliers on the lower end of the cost spectrum. So we have an institution here of around $9,000 a year, and we have institutions that actually are free. What are these institutions, you might ask? They are the military ones. So for example, the Naval Academy or the US Army Academy, which are free in cost. Now, moving on, we have our scatter plot, which graphs the acceptance rate and lower quartile SAT scores for schools. As you can see, there's a lot of data points on this graph. And if we were to draw a line of best fit, it would look something right down the middle right here. So as you can see, because there's a big grouping of these data points, it represents a strong negative correlation. That meaning, as acceptance rate of institutions increases, we tend to see a decrease in the SAT lower quartile score. This would make sense, as less selective institutions would probably require less high test scores. Yep, and all right, well, that's great. And we're gonna move it on to Molly to show you guys some more graphs.
I'm Molly, and I'm going to look at some more data visualizations. So first here we have a side-by-side box plot. What we're looking at here specifically is the institution type compared to the ACT lower quartile scores. So before I get into details of what that exactly is showing us, let me tell you what the selectivity requirements are. So for it to be a most selective college, it needs to be less than 15% acceptance rate. Less than 35% acceptance rate is extremely selective. Less than 50% is very selective. Less than 60% is moderately selective, and anything between 60 and 100% acceptance rate is minimally selective. This side-by-side box plot shows the lower threshold of ACT scores typically accepted by private institution versus public institutions. Both types are further divided by school selectivity. The most selective, the blue ones, private institutions report lower quartile ACT scores above 30, while the most selective public institutions report lower quartile SAT scores in the range of approximately 23 to 28. This box plot suggests that the most selective private schools have higher test score standards than the public schools. And then next we have our heat map, very pretty. It is comparing the alumni salary by state. So this heat map shows on average the average alumni salary based on state, in which school is located at. According to the data set, after 10 years of work experience, alumni from colleges and universities in California and Massachusetts can expect to make upward of $140,000 a year on average. Massachusetts colleges that raise that number is like MIT and Harvard. And then colleges in California that predict that kind of number is Stanford is a big one. While in states like West Virginia, after 10 years of work experience, alumni can make around $90,000 a year on average, according to this data set. And then next we have our inferences. So the first inference we do is the one sample inference. And we decided to do it on average lower quartile SAT scores. We are 95% confident that the mean lower quartile SAT score that all US colleges and universities report is between 1099 and 1120. And then next, our two sample inference is the total annual cost by institution type. We are 95% confident that the average total annual cost of attending a private US college or university is between $15,977 and $19,136, higher than the cost of attending a public US college or university. And next is regression.
Next, we'll move on to regression. The first regression model that we built was a multiple linear regression model on alumni salary. Our original linear model shows alumni salary as a response to acceptance rate, lower and upper quartile SAT scores, and lower and upper quartile ACT scores. Our AIC model found that the best predictors of alumni salary were acceptance rate and both lower quartile scores for the SAT and ACT. According to our multiple R-squared value, approximately 50% of the variability in alumni salary can be explained by the AIC model. And according to our adjusted R-square value, this model was improved 0.19% from the original. Of the three predictors in the AIC model, lower quartile SAT scores had the most statistically significant relationship to alumni salary with a p-value of 1.28 times 10 to the negative sixth power. According to this model, it can be reasonably predicted that if a student graduates from a university that reports an acceptance rate of 17%, a lower quartile SAT score of 1330, and a lower quartile ACT score of 29, they can expect to receive an estimated salary of between $96,827 and $137,654 after 10 years of work experience. The second model that we built was a logistic regression model for financial aid. Our generalized linear model shows aid as a response to institution type, either public or private, total annual cost, selectivity, and campus size. Our AIC model found that each of these was a valuable predictor for quality of aid. So quality of aid was categorized as either good 1 or bad 0 based on the average net price, which is the total annual cost of an institution minus the grant aid provided, being below or above the mean of $22,337. Of the predictors in the AIC model, total annual cost had the most statistically significant relationship to the quality of aid, with a p-value of 8.82 times 10 to the negative 11th power. Holding all variables in the model fixed, for every increase of $1 in total annual cost, the odds of aid being considered good decreases by approximately 0.013%. According to this model, it can be reasonably predicted that if a student chooses to attend a medium-sized private university that is very selective, meaning that its acceptance rate is below 50%, whose total annual cost is $55,000. The odds of their financial aid being considered good is 13.6%. The next regression model that we built was based on selectivity. So the original generalized linear model shows selectivity as a response to institution type, lower and upper quartile SAT scores, and lower and upper quartile ACT scores. And the AIC model found that the best predictor of selectivity was the lower quartile ACT score. So universities and colleges were categorized as either being significantly selective 1 or not, based on acceptance rates falling below or above 50% respectively. Of the predictors in the AIC model, lower quartile ACT scores had the most statistically significant relationship to an institution's selective designation, with a p-value of less than 2 times 10 to the negative 16th power. Holding all variables in the model fixed, for every increase of 1 point in lower quartile ACT score, the odds of an institution being considered selective increases by approximately 77.2%. According to this model, if a university reports an average lower quartile ACT score of 28, the odds that it will be considered selective is 71.4%. And this percentage will increase as the ACT score increases. Lastly, we'd like to acknowledge that the original data set was from Forbes.com and was edited by the following individuals on Kaggle. The information on the Carnegie classification system was retrieved from Indiana University, and the information on college selectivity was retrieved from collegetransitions.com. Thank you.